Hello dear students, hope you're good. Today we're going to talk about chapter 3 section 2, the structure of the atom. Let's start. The structure of the atom. Before we talk about structure of the atom, we must know what's atom. Atom is the smallest particle of an element that retains the chemical property of that element. All atoms consist of two regions. The first one is the nucleus, and the second one is the electron cloud. Nucleus. This is a very small region located at the center of the atom. Look at this diagram at the right side. This is the nucleus, okay? And is very small compared to the size of the atom. So, the nucleus consists of what? Two types of particles, proton and neutron. Protons, they have what? They are positively charged particles. They are positive. Neutrons, they are negative. Okay? Neutrons, they are what? Neutral. Okay. The electron cloud. Electron cloud is a region that surrounds the what? The nucleus. And the electron cloud consists of what? Electrons. Electrons, these are negatively charged particles. Okay? The electron cloud is the region that surrounds the nucleus and the place that we can find what? Electrons. Okay. Subatomic particles. Subatomic particles are proton, neutron, and electron. So guys, we call the electron, neutron, and protons what? Subatomic particles. Okay. Let's talk about discovering of electron. Who discovered the electron? By which experiment? And we're going to explain his experiment. Sorry. The J.J. Thomson discovered the electron while conducting what? Cathode ray tube experiment. Basha? So let's talk about the cathode ray tube experiment. J.J. Thomson brought a tube and he put two metal discs at the end of the tube. From left he put the a metal disc, and the other end also he put a metal disc, and he connected these metal discs to this voltage source, or we can say a battery. Battery is has negative and positive end, so he called that metal that's connected to the negative side of the battery what? Cathode, and he give negative charge. And the one that's the one that's connected to the positive end of the battery, we called what? The anode. Basha, anode is positive. Okay, so then he brought a vacuum pump to take out all the gases inside of the tube. So this decreases the what? The gases inside of the tube. So there's nothing in the tube. Then the tube contains two metals and connected to a battery. So when a current was passed through the cathode ray tube at very gas low pressure, so when you pass the current, it moves from negative to the cathode. Okay, so when he passed the current, what happened? A stream of particles, he called this stream of particles cathode rays, traveled from the cathode to the anode. Look, when he passed the current, what happened? He saw that a beam of particles or rays moved from the cathode to the anode, and he called these rays what? Cathode rays. Why? Because they passed from the cathode to the anode. So that's why he called these rays what? Cathode rays. Basha. Now, to know that these rays, they are wave or particle. So, and do they move in a straight line or not? And to indicate its charge, the charge of the rays, he used three methods. Look, to indicate whether it was a particle or wave, he used a paddle wheel. Look at here, Masha. Look at this diagram. This is the wheel that he put between cathode and the anode. When he put, the wheel was rotated because of the cathode rays. By the cathode rays, these the wheel was rotated. So we know that this indicating that the cathode rays have mass and kinetic energy. That's why the wheel was rotated. If the rays they don't have, if the cathode rays they don't have mass and kinetic energy, how the wheel was rotated? So which means they are not, so they are what? They are particles, not waves. Basha? By this method, he indicated that the cathode rays, they are particle, not waves. Basha. To know that the cathode rays, they pass in a straight line, they move in a straight line or not, he brought an object, Basha. He brought an object and put between what? Between the cathode and the anode. Then he observed a shadow. He saw a shadow behind the object. So this indicated that the cathode rays move in a straight line. Okay. Third method, to indicate the charge, what he did, he brought a magnet and positive and negative plate. First, for the magnet, he neared the magnet. Look at this one. He brought a magnet, Basha, this is the magnet, near the cathode the cathode tube. So when he neared, what happened? The cathode rays were what? Were deflected, changed the direction. So this indicated that the cathode rays, they are negative charge. Why? Because there's a rule when you near a magnet into a negatively charged particle. So what happens? The magnet is going to deflect the negative particles. Pasha? Okay. He used also, to make sure, he used what? Positively charged metal plate, negatively charged metal plate. He neared the tube. What happened? He observed that the cathode rays were what? Were moved to the positive plate. Basha, positive plate. So this indicated that the rays, they have what? They have negative charge. Why? Because negative, positive, they attract each other. So this method indicated that the cathode rays, they are negative. So Thomson called that negative particle what? Electron. This is how J.J. Thomson discovered what? Discovered the electron. Basha. Then after Thomson, who came? Robert Millikan. Robert Millikan measured the charge and the mass of the electron. So in 1909, he successfully measured the negative charge of the electron, which is what? Approximately 1.600, 2 times 10 to the power minus 19 coulomb. This coulomb is the unit that we use for charge. So he measured how much is negative. This is the amount. After he measured the charge, this measurement provided a way to determine the mass of the electron. Means measuring the charge helped him to what? To measure the mass of electron. And he approximately measured, and he said that approximately is 9.1 109 times 10 to the power minus 31 kilograms. Asha? So, after he measured the mass of the electron, he compared with the simplest hydrogen atom. Guys, simplest hydrogen atom, look at this diagram, contains one proton and one electron, and it is the lightest atom in nature. They knew at that time, but they didn't know that there is proton inside of the simplest hydrogen atom. When he compared the mass of the electron is only, he said that 1837 of the mass of the simplest hydrogen atom. It means that the simplest hydrogen atom, one hydrogen atom, is what? 1837 times greater than the mass of an electron. Look, it was very larger than compared to the mass of an electron. Mass of electron was very small compared to the simplest hydrogen atom. Okay, so by this, and he compared that one, and he said that electron is very, very small compared to the mass of simplest atom. Conclusion of the electron experiment. Based on what was learned about electrons, two other conclusions were made about the atomic structure. Let's talk about them. Because atoms electrically neutral. Basha. Atoms, they are neutral. They have discovered the electron. So electron is negative, but we say that atom is neutral. So there must be another what? Positive charge inside of the atom to what? To balance the negative electrons. Okay, so negative and positive, they must be what? Same. Then we say that the atom is neutral. Basha. Another conclusion was, because electrons have so much less mass than atoms, atoms must contain other particles that account for most of their mass. Basha, look at this diagram again. An electron is very small, and they knew that the atom is made of, contains electrons. Basha. So simplest hydrogen atom is very larger than the mass of an electron. They said there must contain, atoms, they must contain what? Another particle which is heavier than the electron and account for most of their mass of the atoms. Okay? So these conclusions helped what? Another scientist, which is Ernst Rutherford, to discover the nucleus. So in 1911, Ernst Rutherford discovered what? Discovered the nucleus. Okay. Rutherford and his co-workers bombarded a thin foil of gold with a positively charged particles, what? Called alpha particle. They were surprised to find that fewer particles in one in 8,000 were reflected from the foil straight back toward the source. This reason that this must mean there is a small positively charged portion of each gold atom. Rutherford called his positive region of matter the what? The nucleus. Okay, let's talk about how. He did his experiment, and his experiment was, its name was gold foil experiment. Why? Because he brought a very thin gold foil, was very, very thin, 0.004 millimeter. So, and he brought a source of alpha particle, and he bombarded the gold foil by alpha particle. Guys, alpha particle, look at you, is positively charged, Basha, and is made of two, and this is proton and two neutron, Basha, two proton and two neutrons. So we say that 4 times is bigger than the mass of simplest hydrogen atom. So, and alpha particle, we can say it's the nucleus of helium. Nucleus of helium made of 2 protons and 2 neutrons. Basha. When he bombarded, few of the alpha particles positive, were reflected back. So he said there must, the gold atoms must contain what? Must contain a positive portion. Why? Because positive reflect each other. Few of them, 1 in 8,000 reflected back. He said there must be very small portion inside of the, look, some of them reflected back. He said that there must be very small portion inside of the gold atoms. That's why they reflect the gold, the alpha particles. Okay, Rutherford called this positive region of the matter what? The nucleus. Pasha. This is the atomic model of the Rutherford. It's called nuclear model. So look, he said all the positive charged particles, they are concentrated in a very small region in the atom. He called this positive region of the atom what? The nucleus. Okay, this is how Ernst Rutherford discovered the nucleus. Pasha. Guys, these are atomic models. According to the Dalton, this is how was the atom. And the Thomson, look, he said that there are electrons, and some conclusions were made. We said that the whole atom is positive, and electrons, they are equally spread inside of the atom. That's why there's a big plus. Means the atom is like watermelon and seeds. The watermelon is positive charged particle, and the seeds, they are what? These are the electrons. They are very small in mass. Nuclear model of the Rutherford. This is, he said, all positive charge, they are concentrated at the center of the atom. Then we will talk about Bohr's atomic model in chapter 4 section 1 and quantum model in chapter 4 section 2. Basha. Composition of the atomic nucleus. Composition of the atomic nucleus. Guys, in the nucleus of each atom, we have proton and neutrons, except the simplest hydrogen atom that contains only one proton and doesn't contain neutron. Look, it's written, except for the simplest hydrogen atom, nucleus of the simplest hydrogen atom, all atomic nuclei consist of two particles, protons and neutrons. Basha? Okay. Protons have a positive charge while neutrons have no charge. Neutrons, they don't have charge. Atoms are electrically neutral because the number of protons is equal to the number of electrons. Atoms, they are neutral. When they are neutral, they don't have charge, means protons, electrons are same. Okay, they don't conduct electricity. So a proton has a mass. Let's talk about mass of proton, neutron, electron. Mass of proton is 1.673 times 10 to the power minus 27 kilogram, which is 1,837 times greater than the mass of the electron. Okay, mass of proton is much bigger than the mass of the electron. What about neutron? Neutron has a mass 1.675 times 10 to the power minus 27 kilogram. It's slightly larger than the mass of the proton, right? Look, 73, here's 75, slightly. So we can say neutron is bigger, is larger than the proton, and proton is larger than the electron by mass. Okay. The nuclei of atoms of different elements are different in the number of protons. Look, number of protons different between the atoms of different elements. Atoms of different elements, they have different number of protons. Basha? Subatomic particles indicate what? The properties of an atom. Well, you know, subatomic particles, we mean proton, electron, neutrons. So they indicate the properties of the atom. Why atoms of different elements are different? Because what? Because they have different number of protons, electrons, and neutrons. Basha, look at this table, properties of subatomic particles, electron, proton, neutron. Their symbol, this is just, you don't need to memorize this now. So this is the symbol. This is symbol of proton, symbol of neutron. Basha. Relative charge, electric charge, negative one is for electron, positive one is for proton, 0 is the charge, electrical charge of the neutron. Mass number, we will talk about mass number. Why electron is 0? We don't count the mass of electron when we measure the mass of the atom, because it's very, very small. Basha, proton is 1, its mass number, neutron is 1. Basha, the mass of the electron, proton, and neutron. For the electron, this is AMU, guys. AMU means atomic mass unit. Basha, atomic mass unit equals 1.660 times 10 to the power minus 27 kilogram. Also, we can say the actual mass in kilogram. Basha, this is in kilogram, this is in AMU. Later we'll talk about AMU. So these are in AMU. Why we use AMU? Because in kilogram it gives us very small mass. Okay? Basha, mass of electron is 0.005,486. This mass of proton, mass of neutron. Look, neutron is slightly larger than the mass of proton. So the massive particle in atom is what? Is the neutron. Okay. Forces in the nucleus. Forces in the nucleus. Guys, we have proton, neutrons inside of the nucleus. So what force hold these together, these protons, neutrons? We know that protons, they repel each other because they have same charge. Why they don't repel each other in the nucleus of the atom? We say that when two protons are extremely close to each other, there is a strong attraction between them. A similar attraction exists when neutrons are very close to each other. When protons, when group of protons are very close to each other, the repulsion force changes to attraction force. Also, a similar attraction exists when neutrons are very close to each other. There is a strong attraction force. We call this strong attraction nuclear force. What's nuclear force? The force of proton, neutron, proton that hold the nuclear particles, hold these particles together. Basha, this is the definition of nuclear force. It's not mentioned in the book that neutrons help the protons to not repel each other. Okay, as well. The size of the atom. Look, atoms, they have size. And atoms of different elements, they have different sizes. Basha? How we can measure the size of the atoms? By measuring the radius of the atom. The radius of an atom is the distance from the center of the nucleus to the outermost shell, the last shell. Look, this is the center of the nucleus and this is the outermost shell. Okay, so the distance from the center to the outermost shell is what? Is the atomic radius. Okay. Atomic radii is so small, expressed by picometer. The size of an atom is very, very small. We don't use meter, centimeter. We use what? Picometer. 1 picometer equals 10 to the power minus 12 meter. Basha. We have a range. Atomic radii range from about 40 to 2,270 picometer. Basha means the smallest atom in nature, it has 40 picometer. Largest atom in nature, it has a size which is 270 picometer. Also, nuclei of atoms, they have size, but it is very small compared to the mass of the atom. It's about 0.001 picometer. Okay, this is the end of the lesson. This is section review answers. Thank you very much. Inshallah, next time we will talk about chapter 3, section 3, counting atoms. Okay, goodbye and see you.